Alright, so we're doing geometric series, doing example 1, which is the which states that summation from n is equal to 1 to infinity of 1 plus 2 to the nth power over 3 to the nth power. So in looking at this series, your first step is pretty much going to be to rewrite this series as a sum of two series. And so in order to do that, you have summation from n is equal to 1 to infinity of 1 over 3 to the nth power plus summation from n is equal to 1 to infinity of 2n over 3n. Okay? So your first step is you're going to solve the first series, and then you're going to solve the second series, and then you're going to add the two together in order to find out what this is equal to. So I'm going to rewrite this. Summation from n is equal to 1 to infinity of 1 over 3n. Okay, so your first step is going to be to expand this series. You're going to need to expand it. And so this is going to be 1 over 3 to the first power, because we're starting at n is equal to 1, which is just 1 over 3, plus 1 over 3 to the second power, because now n is equal to 2. We're going to continue to increase by increments of 1. So you have 1 over 3 to the third power, plus so on and so forth until you get to 1 over 3 to the nth power. And that's going to be how you expand your series. So now your next step is to find your A, where A is equal to, where R is equal to. And so in order to find that, you need to look at what exactly a series is. The series is A plus AR plus AR squared. And that's how you find, well, plus AR to the nth power. Alright, so looking at this, we're going to match this up. A is equal to 1/3 in this case, and then R is equal to 1/3 as well. Because we see here we have 1/3 squared, which is 1/3 times 1/3. And if A is equal to 1/3, that's first 1/3, then that means that R is equal to 1/3 as well. Okay, so now you need to look and see if this is a geometric series and if it converges. And in order to do that, you're going to look at your R, and you're going to see if whatever R is equal to, whether or not it's less than the absolute value of R, of that number. So the absolute value of 1/3 is less than 1, which means that this is a geometric series, and it means that this series converges, which means that we can continue on to find the sum of this series. And the sum of your first series, because remember we have to do a second one. So sum 1, sum 2. So the sum of your first series, which is the one we're working on now, is equal to A divided by 1 minus R. And so pretty much we're going to plug in, we're going to solve, we're going to find the sum of our first series. So we have 1/3 divided by 1 minus 1/3, which is equal to 1/3 divided by 2/3. Sorry. Yeah, divided by 2/3, which is equal to, we're going to multiply by the reciprocal of the denominator in order to get the fraction off of the denominator. So we have 1/3 times 2/3, which is equal to, times 3/2, sorry about that, which is equal to 3 over 6, which is equal to 1/2. So therefore we know that the sum of our first series is 1/2. So I'm going to put this up here. Alright, so now the next step is to find the sum of our second series. So I'm going to erase this. And pretty much we're going to do what we did for the first series again for the second series, except one detail. Well, it changes a little bit. So we have the summation from n equal to 1 to infinity of 2 to the nth power over 3 to the nth power. And so there's another way that we can write this. And our basic math tells us that this is equal to that. We already know that those two are the same thing. And so now by looking at it this way, we can figure out how to expand our series. And so in order to expand your series, you have 2/3 to the first power, or simply 2/3, because again we're starting with n equal to 1 when n is equal to 1, plus 2/3 squared, because n is now equal to 2, and we're going to go up by increments of 1, 2/3 cubed, plus so on and so forth, 2/3 to the nth power, plus so on and so forth. So now we're going to match up our expanded series for this case with our general knowledge of what a series is. So a series is, again, A plus AR plus AR squared plus AR to the nth power plus. Okay. So now we need to find out what A is equal to, and we need to figure out what R is equal to. So in this case, A is equal to 2/3. And R is equal to 2/3 as well, because if we look here where we have our R, A times R, we have 2/3 squared, which is 2/3 times 2/3. And we already know that A is 2/3. So that means that R is 2/3. Now we need to figure out if it's a geometric series, one, and also if it converges. And by doing that, you're going to look at what R is equal to. If the absolute value of what R is equal to is less than 1, which in this case it is, we know that our series is not only a geometric series, but also that it converges. Which means that we can move on to finding our sum of this series. Alright, so sum of your second series is equal to A divided by 1 minus R. Again, nothing has changed except what A is equal to and what R is equal to. So in this case, we have sum of your second series is equal to 2/3 divided by 1 minus 2/3. So S2 is equal to 2/3 divided by 1/3, which is the same thing as 2/3 times 3/1, or 3, which is equal to 6/3, which is equal to 2. So by doing that, we know that 2 is the sum of our second series. So we have 1/2 plus 2 . And by breaking it up into two different series, finding the sum of those two different series, we end up with the sum from n is equal to 1 to infinity of 1 plus 2 to the nth power over 3 to the nth power is equal to 1/2 plus 2, which is equal to, just going to write it all out, 1/2 plus 4/2, which is equal to 5/2. Which 5/2 is the sum of your original series, which is the summation from n equals 1 to infinity of 1 plus 2 to the nth power over 3 to the nth power.